All right, hi everyone. So today we're going to go through some lab equipment and glassware. Normally this is one of the very first things that we do to help prepare you for doing some wet chemistry labs. And it's important to know what the different pieces of equipment are called. So it's with a little bit of bittersweetness that we're going through this now because we won't be in lab at least until October, and unfortunately I suspect probably not until second semester. That being said, I'll still be doing some labs that I'll demo for you. I'll be doing demonstrations, and it's good for you to know these. If you're a first year student, you probably know some of these, like beakers and graduated cylinders. And it's worth knowing the other ones. If you're a second year student, maybe you're a bit rusty. So this will be a good refresher. So you should have this PDF, should have access to it. It's just 2 pages, front and back. I'm going to be going through a PowerPoint where I show you pictures of the different pieces there. So yeah, we'll just go ahead and get through here. I'll also make this PowerPoint available so you can go through it when you have a chance. All right, so first, you already saw the name here. This is a graduated cylinder. It's so called because the lines are otherwise known as graduations. And those lines allow us to very precisely measure volumes. And so this is what you would use primarily in this class to measure a certain volume if we do need a specific and precise amount. If you need a really precise amount, there are other pieces of equipment that we can use, but this is a good utility piece. This one you're probably not as familiar with. This is what is called a volumetric flask, and it's characterized by only having one graduation. And so if you look really carefully here, it says 200 mils plus or minus, and that actually says zero point 0.1. So that means if you get it right to this line, you have a volume of 200.1 to 199.9, which is very, very precisely measured. So this is the kind of instrument you would want to use if you need a very precise volume. It does also have a cap. We will use these second semester during our acid base unit to precisely measure the concentration of different acids or bases. The limitation, though, is this is only good for 200 mils. You can't use it for any other size. So that's our volumetric flask. We also have this one. This one has kind of that roundish shape, but it has a flat bottom. This is called the Florence flask. Now notice it has no graduations. So you wouldn't use this for measuring. This is for holding chemicals, for doing reactions, and it has that nice narrow top so that you can seal it with like a rubber stopper. So that is our Florence flask. Okay, this one, and you can follow along on your sheet if you wish. This is what is called a wash bottle. The word on your sheet there is polyethylene. That just describes the plastic. That's not important. So if you look at this curved neck here, that's actually a nice design feature because you can use that to point it into a different flask and then spray water to maybe swirl around solid that has been stuck. So it's not really used for washing per se as it is to kind of rinse certain things. Okay, you ought to know this one. This one, of course, is a beaker. Notice how few graduations this has. So a beaker actually is not what you'd want to use if you needed to measure a specific volume. But if I sent you over to lab and I said, hey, go ahead and measure out 50 mils, then sure, a beaker is great. Okay, moving right along. Number 6, this is what is called a burette. Now I have a couple pictures here because it's a little hard to see. So it's one long tube and it has this valve at the bottom. And here's a close-up of this. And on the tube itself, it has graduations like a grad cylinder. So here's the deal. This valve is able to close or open and all the degrees in between. So you can use the graduations to measure a very precise volume, and you can open and close the valve to deliver even a single drop. And in fact, when we use these next semester for acid-base chemistry, we will often want to have it down to a single drop. This one, if you follow along, this is called a transfer pipette or a volumetric pipette. Kind of like a volumetric flask, it only has one line. You have to use a bulb, a ProPipette bulb or the like on the end of this. And what you do is you put the tip here into the liquid, you squeeze the bulb, and then you use it to pull out a certain amount. Now, if you notice, this is only for one volume, kind of like the volumetric flask. This is only good for 100, so you'd need different sizes. The more pipette is on your sheet, I'm not going to cover that because honestly, we just don't use those. If you go on and take more chemistry, you will certainly run into those. All right, and of course, you ought to know this one. This is just thermometer. Okay, and actually, it's really hard finding a picture of a thermometer. This one you can see has that silver tip. That's a mercury thermometer. We don't use those because, hey, mercury is a neurotoxin. How about that? So ours are either red or blue, which actually is just dyed alcohol. And we'll be talking more in the coming days about how to accurately read the measurements using the graduations, but you all know how a thermometer works. Okay, this one is not on your sheet, but it's worth knowing, and this picture is not great, but we have kind of a flat end right here and a spoon on this end. This is what is called a spatula. And I think it's a spatula because it has this flat end, kind of like an actual spatula, but you would use this to measure out or transfer, certain solids. Like let's say you're measuring out salt, you could scoop it out and then, put it on a scale. So we will use these quite a bit when we were back in lab actually measuring chemicals. All right, moving right along. So here we have a glass stirring rod on the end of which is a rubber policeman. Stirring rod, self-explanatory. Most of our stirring rods are just stirring rods. The rubber policeman is nice if you are transferring a solid and a liquid and you want to, scrape the leftover solid into the next container, but honestly, we just don't use them. Okay, so here we go. This is one of the quintessential pieces that people think of when they think science. So this is what is called an Erlenmeyer flask, right? It's very phonetic, Erlenmeyer flask. Has that kind of cone-shaped bottom with a narrow top. Similar to a beaker, it doesn't have a ton of graduations. So again, probably not using this to measure out liquids, probably using this to hold chemicals or to do reactions with. Now this one looks an awful lot like an Erlenmeyer flask, but if you notice it has this additional piece. This is what is called a filter or sidearm flask. And what you would actually do, you would use this for filtering. Imagine that. And you would take this end and hook it up with a tube to a vacuum pump, and then you put a filter up here on the top to filter out a solid from a liquid. So hopefully when we're back, we can actually do a lab where I ask you to separate a solid from a liquid, and you would use this kind of device for that. Okay, this one is self-explanatory. This is litmus paper. And it's too bad we're not doing a quiz in person because I would literally walk around with this and wave it in front of each and every one of your little faces. So it was kind of a gimme and always kind of a joke. These are used to test the pH, or more specifically, whether something is an acid or a base. They're very inexpensive. It's a quick test. You dip these strips into your solution, and depending on how the color changes, you get your answer. It doesn't tell you the actual pH, so it is limited in that way. But let's say that I'm in my lab and there's a mysterious liquid and I have no idea what it is. A quick and inexpensive test I could do is dip a little pH paper in there to see whether it's an acid or a base. And of course, it could also be neutral. Okay, so this you've used before, seen before. This, of course, is just a test tube. No big surprise there. And especially if you're heating something up with a test tube and or you're transferring, let's say a really concentrated acid that's corrosive, you would want to use a test tube holder. And it's a little hard to tell from this, but you would squeeze this part of it with your fingers, and then this part opens up to take on the test tube. So that's a test tube holder. On this front page, I did skip medicine droppers. We don't tend to use them. Test tube brushes we do use, but I think those are pretty self-explanatory. All right, so go ahead and flip it over to the back. We do have several different types of funnels. I think you probably would recognize this as a funnel, but I do want to point out that this one is specifically used for liquids. If you notice, the stem is very narrow, it's not very big, and it's long. This is ideal for liquids because it helps control the flow and the movement. And you might be thinking, well, who cares if a little splashes? Well, what if you're measuring that volume precisely and then you end up losing some of that liquid? when you go to transfer it. Well, that's a problem. What if you're measuring out like super concentrated, nasty acid? You don't want that splattering around, right? That leads to a bad day. So that's going to be used for liquids. On the other hand, we have these funnels. Now, notice the difference. It has a much shorter stem and it's much wider. So this is ideal for transferring powders or solids. If you used a liquid funnel, chances are good the solid could clump up in there and clog, right? And then you're not in a good place. Okay, this one is called a Buchner funnel. Those of you who take German, we actually need an umlaut over the U, but I'll be honest, I was just kind of feeling lazy. So if you can see here, this has little holes, and this is otherwise typically made of plastic or ceramic. And so what you do, and I'm going to go forward for a second here, is you need a specifically sized filter paper. Again, that's another gimme I tend to give students on that quiz. And that goes into your Buchner funnel. And so you remember when I showed you that filter flask? Well, this goes on top of the filter flask. You put the filter paper in, and then you pour your solid and liquid mixture in through there. The filter paper stops the solid, allowing the liquid to go through. Okay, so hopefully we're back in the spring and we can do a separation lab where I ask you to separate, a solid from a liquid. So Buchner funnel and filter paper. Okay, moving on to this. This is a very important piece of equipment. It's a very useful piece. This is what is called a ring stand. And as the name implies, you have this solid stand with this stainless steel post that comes out. Unto itself, it's not useful, although it is handy for beating students and or intruders alike. It's what you can do with the ring stand, what you can attach to it. So one thing you can attach to it is what we call wire gauze. Now, wire gauze has typically a heat-resistant material in this wire mesh. And what you would do is you would use this as a platform to hold, let's say, a beaker on the ring stand where you can alter the height. You can elevate it or lower it as you need to. But you can't actually use the wire gauze unto itself. So I'm actually going to skip ahead for a moment because you would need to use what is called an iron ring. So this guy right here, this is what attaches to the ring stand. You have this open hole, and then you would place the wire gauze on top of your iron ring, and that gives you a nice steady surface for, like I said, heating up a beaker, for example, ring. So I do affectionately refer to this as the iron ring of death because iron ring to me just sounds like a torture device. I'm not sure how you could actually, hurt someone with this, but I'm sure we could come up with a way if we really put our collective imagination into it. Okay, so let me go back because I did skip this guy. So this is what is called a double burette holder or clamp. And what you do is you would squeeze these two things with your fingers, and that opens the junction here, and then you would slide your burette in there and it holds it nicely. It's very quick. It's very easy to put up the burette or remove it. In the spring, we will definitely be using this when we do our acid-base titrations. All right, so this is a clay triangle. This would also be positioned in the center of the iron ring, right? It just kind of goes and drapes over there. We don't use these a ton, to be honest. The reason why they're shaped this way, first of all, the clay is very heat resistant. So if you were doing a high heat application, you could use this. This is designed to hold a crucible, which fits right in the center. And we'll get to the crucible here in a minute. This is what is called a watch glass. We do use these quite a bit. Sometimes they're nice to put on top of a beaker. It doesn't seal it, but it kind of contains like any nasty fumes. We might also use it to collect solids as kind of like a little plate. So it does have a variety of purposes there. This is the crucible that I mentioned in the previous slide. So this is what would fit into your clay triangle. It's made of ceramic, and in case you're not aware, ceramic is like crockware. It's able to take on a significant amount of heat. So if you just need to heat the heck out of something, you wouldn't want to use a beaker because you can heat in glass, but it has its limits, whereas ceramic is, super sturdy. It also has a lid if you need to contain whatever it is that you're heating up in there. So that's our crucible with lid. This one we will use quite a bit. This is what is called an evaporating dish. And if you look at the little spout right here, that is on purpose. So it's similar to a crucible where you can do a high heat application. But let's say you want to boil off material, but you're afraid you're going to lose some of your chemical. You can put a watch glass around the evaporating dish, and this little spout allows, let's say, the steam from the water to escape without having to seal the container. So we'll use these evaporating dishes quite a bit. All right, moving on, these are what are called crucible tongs. If you look at the shape, that shape right here is perfect to hold a crucible. So imagine you just heated the heck out of a crucible. You don't want to pick it up with your hand. So these are designed to help pick those up and move them to safety. They're also just kind of utility clamps that we can use for various purposes. So that is, those are our crucible tongs. What is probably more useful for us, and this is not on your sheet, are these. These are called beaker tongs. And if you look at the shape of these, that allows for a lot bigger space, and it allows you to firmly hold on to a beaker. One of the lessons we'll talk about when we do get back is that hot glass looks just like cold glass. And so you always want to be careful. And if you are heating something up in a beaker, you don't want to try to move it with your hand. So you would want to use beaker tongs to safely pick that up and move it to the next location. All right, so this is our utility clamp. This part right here is where you would put the ring stand. So this will slide up and down kind of like an iron ring. And it has this adjustable neck. And so if you think about the shape of that, what maybe could you use that for? Well, probably not a beaker, unless it was a really teeny tiny beaker. But if you think about that shape, that's perfect for the neck of, let's say, an Erlenmeyer flask, or for a test tube, that sort of thing. So if you need to elevate a Erlenmeyer flask or a test tube, you could use that utility clamp to get it off the table and to have it being held so that you can do other things to it. A lot of the other clamps on here on the paper, I'm going to leave off because quite frankly, we don't use them. So I see no reason to go over them. All right. So here is our Bunsen burner with rubber tubing. I'm combining these because you can't really have one without the other. The tubing connects right here and it hooks up to one of our gas outlets. As students in chemistry, we do try to get you to be able to use these things comfortably. It's a little scary to light these, but once you get the hang of it, it's pretty cool. So hopefully when we come back, you will be able to use that. And there are different adjustments you can make by opening and closing these valves to allow the air in different ratios with the fuel mixture. Again, those are all things that we'll play with when the time comes. So yeah, Bunsen burner and rubber tubing. Now, this one is also not on your sheet, but we sometimes use these, and maybe you have one at home. This is called a mortar and a pestle. And these are ceramic, heavy-duty things that you can use to grind solids. Let's say that we had a solid like kosher salt, like really big crystals, and I wanted you to grind it down into a finer powder. You would go ahead and put it in the mortar and then hold on to the pestle and just go around in circles, and the ceramic on ceramic friction and the heavy duty nature of it is able to break those down into smaller sizes. All right, this one is one that we'll use occasionally. This is what is called a well plate. So you have these individual chambers. And the advantage of this is you can do multiple reactions simultaneously. And then you have them right next to each other so you can visually compare. A lot of chemistry, you actually don't need large quantities to do what you need to do. There's even experiments we'll do later in the year where a few drops of each chemical is enough. And so this is a really nice organized way to do a lot of reactions quickly and efficiently. These, of course, are safety glasses. When we do come back, we will need to have these, and normally we have a class set, but that doesn't seem sanitary. So I think in this pandemic landscape, we're going to need everyone to have their own glasses. We can sell new, and certainly we can work it out if cost is an issue. I'll talk more about it later, but protecting your eyes is really quite critical. So you probably have used these before, hopefully. especially in junior high. This is a triple beam balance. It's a way for us to mass something. We won't use these a ton. We will more often than not use an electronic balance. And we'll talk more about these, but this is a way for us to measure a very precise mass of different objects. And that's what we have. So you're not going to have a quiz over these, but I would appreciate it, especially for you first year students, to look over these, be familiar with them, try to learn them. They will come up again. For you secondary students, or your second year students rather, yeah, just quick review. You're not going to have a quiz over it, but I would like you to know these.